Hello and welcome to my RailsConf Couch Talk. Today I want to talk to you about what it means to build understanding and improve communication through visual art. If you want to get in touch with me, my Twitter handle is at the bottom of this slide and the next. Quick introduction to me. My name is Anna Rankin. I am the tech lead on the EdTech team at the education company, General Assembly. I work with some excellent humans on the software that powers our in-house student and administrator tools. Before that, I was a web development instructor at the same company. I have a BFA in illustration from the School of Visual Arts. I create a lot of pixel art, stickers, and really great puns. In addition to my sticker problem and my pixel art addiction, I like to push the limit of the custom emoji as art form in Slack. Although honestly, since I live in New York City in the time of quarantine, it's been a lot more Animal Crossing than productivity. And that's okay. Today, we're going to talk about how you, as a technologist, can use the creation and dissemination of visual art to train yourself, train others, and get in touch with the depths of your own knowledge on a given subject. A little bit about me and why I care about this stuff. So I don't have a CS degree. I never considered myself to be very good at math. I spent a lot more of my time drawing dogs than making websites. So as a person from a non-traditional background, who's now working in a very technical field with a lot of topics that aren't familiar to the general public, I've been able to use my artistic abilities to my advantage. This didn't come immediately, but I found that I could communicate my ideas better with my teammates when I drew them out on a whiteboard or a scrap of paper. It was helpful to be able to sketch out what I was thinking and see how my coworkers' thoughts fit into mine visually. As an added bonus, gaps in my knowledge became clear very, very quickly. As I began to take a larger role in designing architecture and mentoring other people, this ability to represent complex topics in a simplified way has helped me a whole lot. I tend to use visual tools every step of the way, whether I'm working with a staff engineer, a summer intern, or just brainstorming on my own. What it all comes down to is using different lenses, or different ways of thinking, to examine what you know and build the understanding of people around you. There are two specific problems I'm going to tackle today. One is using drawing as a way to clarify what you don't know, and two, as a way to help explain the things that you do know. The main reason I became a developer on a product team was in order to solve problems for people that I cared about, in this case, teachers and students, on a larger scale than I could without software. A lot of other important considerations go into becoming a developer, but if you're not delivering something of value that people are actually going to use, what's the point of the effort? If we want to solve anything for anyone, we first need to understand the problem at hand and the tools that we can use to solve it. The more we understand about the ecosystem that we operate within, the more informed our decisions and overall approach to the problem will be. This quest for deeper understanding is something that we have in common with artists. We're both in pursuit of a higher understanding of the world around us or of some deeper philosophical truth. But wait, you say? I can't even draw. This has nothing to do with me. I say you're wrong. Everything that you can do now, everything that you're an expert in, and you do have expertise, you once had to start from zero with. So please don't let inexperience or a lack of formal schooling stop you from experimenting with new skills and new ways of seeing. If I had done that, I would probably still be a graphic designer and be miserable. Let's jump right into building understanding. We're going to use drawing as both a learning and a diagnostic tool for our own knowledge, stored in our brains. The drawing process is a lot like the development process in a lot of ways. There are skills and techniques that are taught formally in art school that can be exceedingly helpful during the learning process. I'm going to introduce a few tools from the Illustrator's toolbox to help you work through technical problems and teach others. Drawing from observation, for example, is a key tool in any artist's toolbox. This is important because before you can solve a problem or learn something new, you've got to know your goal. How do we even figure out where to start? By looking. Drawing from observation allows you to practice hand-eye-brain coordination. You can sketch out unfamiliar features of a subject that's already familiar to you. Basically put things in context to the general idea that's already in your head. Without first carefully observing the source material that you want to understand, you can only hope to depict an object or a concept based on what's already in your head. If you're learning something new, that's not what you want. You want to bring in new information, elaborate on what you already know, and put that additional information into context in your brain. When it comes to software, this might mean keeping the documentation, your application, the code base, or other artifacts open while you draw or write out your ideas or take notes. You're just going to try and confirm that what's in your head matches up with what's in reality. For example, say you had a question, how do I add a new route to this Rails app that hits a given controller? The first place that I would start to look for that would be at the documentation. The Rails guides are actually fantastic, and they're how I learned how to use Rails. Once you look at the documentation, though, you're going to start noticing new questions pop up. You solve one problem and another one comes up, and that's progress. So why aren't these parameters coming through? What if this route is nested? Does that change the controller it goes to? What's going on here? So you're going to come up with new questions. You can dig further deeper into the documentation. I also love using pry as a playground. So just throw a binding.pry somewhere in your code, play around with things, see how things work, and then record your findings so that you have it to look back on later. Once you've identified what it is that you're trying to learn or understand, it's time for the sketching phase. You're translating what's in your head onto a piece of paper, which is a weird and difficult process if you've never done it before. For an artist, this is where a rough draft of the final composition comes together. So sketches, though, are ephemeral. They're meant to be destroyed or thrown away. So now is not the time to worry about accuracy. Think of it as a rough draft of what's in your head. This is the stage where your brain digests all of the scattered little bits of information that you've given it and begins to synthesize it into a cohesive whole. Getting it all out on paper frees up some working memory in your brain, and it allows you to examine your knowledge without having to keep it all in mind at once. Just don't have enough room. It's not possible. This picture shows how knowledge of different individual features can be combined to paint a fuller, more complete portrait of a human being. Each individual feature is important to understand, but it's the relation of the features to each other that makes this a recognizable, accurate portrait. I found this awesome study from 1996 that talks about drawing as a means to have a conversation with paper. The same way that you rubber duck with your coworkers, you can also use a drawing as a sounding board. I liked this quote a lot. Sketching on paper and pencil supports ambiguity, imprecision, and incremental formalization of ideas, as well as rapid exploration of alternatives. What this means to me is that drawing out a new idea can help you formulate an approach by encouraging experimentation and iteration on an idea. With code, you have to know exactly what to tell the computer in order to get your idea, working. With a drawing, you can be a lot more hand-wavy, and that gives you a lot more flexibility in what you're doing. This concept was also referred to in the paper as thinking with a pencil. I really liked this thought by drawing and looking, designers find visual analogies, they remember relevant examples that are related to what they're working on, and they discover entirely new shapes based on unrecognized geometric configurations in their sketches. I find this absolutely fascinating. Your brain links different ideas and experiences together in a lot of ways, and putting that down all on paper allows you to take a look and draw parallels to prior knowledge. It's really, really helpful. Once you've got an outline of what you know laid out on paper in front of you, it's time for critique and refinement. You can erase some parts, add others, maybe propose different configurations, solicit feedback. You can keep this drawing in your head as a mental model of how things work and refer back to it later. Added bonus, as long as you have this high-level idea of what's going on, you can keep adding to it. You can keep it up to date, and you have a strong model that you can use to contextualize new information as it comes in. Pretty cool. While you're doing all this, it's important to remember that the end result is not nearly as important as the process you're going through to get there. This is not the time to be precious with your work. Story time. When I was in art school, one drawing class in particular was infamous for how it was taught. It was an observational drawing class that ran for 3 months, 6 hours a week. Each session, students would spend hours working on a single drawing of the same model in the same setting, position, and lighting. After a final critique of their work, the instructor issued a cruel-sounding instruction. Take that drawing you've created and erase the entire page. His message to the students was, you've done it once, and now you can do it again. You know how. This approach may have been a little heavy-handed, but it definitely drove the point home. The most valuable thing that you wind up with in the end is your improved skill, not a single drawing or a painting. So don't be precious with your artwork. Once we've built this understanding up and we have a strong proposal or mental model and have a goal in mind, it's time to share it with others. I'm going to talk about different formats and types of illustration, where best to use those, and share some tips for creating clear and compelling imagery. So this here is an excerpt from Wikipedia's article on the publisher-subscriber pattern that I found when I was looking up how it worked. If you're anything like me, your reaction to a wall of text that describes an unfamiliar topic is something like this. What? So I had a ton of information in front of me. Without context, though, I had very little understanding. I found this diagram in Real-Time API's documentation, so props to them. It made different parts of the system it described a lot clearer to me. Like I see the publisher, I see the channel, I see the messages going through to the subscribers. It seems so simple when you look at it here. It means it's a good illustration. This gave me a really nice high-level shortcut to keep in mind and refer back to while I got deeper into the documentation. This brings us to keeping your goal in mind when you're creating illustrations. Is this something that's going to be put in an architecture proposal? Is this an illustration of a problem that you want to show to your team? Is this going to be accompanying a blog post? Are you creating documentation for your team or for end users? The function of your visual aid will heavily affect the form and the content, so it's helpful to nail this down in advance. Illustrators do this all the time. Let's really quick define what illustration is. So in general, an illustrator's goal is to bring illumination to what is obscure, to clarify or enlighten. It could be an example that helps make something clear, or a picture or a diagram that makes something clear or attractive. Thank you, Merriam-Webster. Even within this definition, though, there's an entire world of variation depending on what the artist wants to communicate. I wanted to use Yuko Shimizu's editorial work as an example of a strong conceptual illustrator. Rather than depict processes or create portraits, she tackles the much more elusive job of illustrating concepts. These images depict online shaming, dusting off the male gaze, and tolerance in turn. Yuko was an instructor of mine when I was in school, and she is a wonderful human. If you're interested in the process behind these images, she has a really great sort of step-by-step on her website, so highly recommend checking that out. Another artist that I love is Andy Rash. I love his pixel art portraits. He's a large part of what inspired me to actually get back into pixel art and create it again. This is an example of taking minimalism to an extreme, without losing the gist of what you're trying to get across. In this case, he's showing a likeness or a portrait. He's able to create a recognizable image of a celebrity using the least amount of detail possible. That's hard to do and very impressive. Speaking of impressive, Ernst Haeckel was a German zoologist and an artist, among many, many other things, very, very much a Renaissance dude, who discovered, described, and named thousands of new species. His work is a good example of scientific illustration. These drawings are precise in a way photographs can't be. They highlight the important features, proportions, shapes, and textures of the creatures he was depicting, while leaving things like irrelevant light and shading, backgrounds, unrelated debris out of it. It's also beautifully done. He's exacting and detailed, just as you'd expect a scientist to be. In software, conceptual illustration is still extremely useful. Maggie Appleton is an art director and the lead illustrator at egghead.io. She creates fantastic visual analogies ranging from simple concepts to extremely complex ones. Highly, highly recommend checking out her website for more very good examples. Illustrations like this are especially useful for beginners, but they're still awesome for advanced audiences. It's great if you can meet your audience on familiar ground to lessen the barrier to entry for your explanation. Analogies are wonderful in general for communicating understanding. So these two pictures are examples of visual analogies that I came up with to answer the question, what's the difference between two identical objects in JavaScript and Ruby? The first is a more general illustration that frames the question. Would you be equal to your clone? Are you the same person? Do you have all the same attributes? The second one is more specific, and it shows the philosophical differences between how Ruby and JavaScript treat data structure equality. This second one is a shortcut to a mental model that I have in my own head that I wanted to share. JavaScript equality works on identity. So is this the same box? No, it's not the same box. It's not equal. Ruby looks at the attributes of an object, looks at these two boxes. Same stuff in this box? Yeah, they're equal. So it's just a philosophical difference. This example gets a little closer to the scientific illustration side of things. It's an example of a diagram that I created to show how our system would integrate with an external system. So this external system routes the users to a show page for a given thing with a specified ID along with a secret. Our server checks to see if the thing exists and if the secret token provided is valid. If both those checks succeed, we display the thing. If they don't, we 404 and we don't even tell them that there was a thing to begin with. Obviously, some details have been changed, but a simple illustration like this is a great entry point for keeping the overall flow in someone's mind as they read your proposal. For the purposes of this talk, I'm going to encourage you to think like a scientific illustrator, someone who brings clarity and simplicity to the way that complex things work. Be the Hegel you want to see in the world. So that brings us to what makes a good illustration. So I'm going to share a couple of tips for accessible, effective illustrations. Before you can draw out an illustration, you've got to know where your audience is starting from. If you're teaching, for example, you should know the experience level of your students and their familiarity with the topic that you're addressing. For example, are you teaching a brand new cohort of people who have never touched programming before in their lives? Are you teaching Ruby to someone who already knows JavaScript? How can you tie into what they already know to give them some new knowledge? One way you can do that is to use familiar symbols and language. So when presenting a new or complex topic, the best way to lower the barrier to entry is to make it easier for your learner to kind of lean on the knowledge that they already have. One reason learning to code is so difficult that not only are you having a ton of new concepts thrown at you, you're also expected to learn the syntax of a new language at the same time. Using familiarity to make this a little less intimidating and add some clarity is a lot way to tap into what your audience already knows and make it a little bit easier for them to ramp up. For example, if I asked you to explain what a hash was, how might you answer? It's kind of a tough question. Is a hash a container for a set of keys and values? Great! What does that actually mean? Is it a bag? Is it a bucket you reach into and keep checking to see if you got the thing you wanted, throw it back if it's not? Or is it more like a filing system where you look up values by the label that you put on a folder? As you think about this, keep in mind which representation makes the most sense and conveys the most truth to the learner. If it's simple but wrong, it's not going to help you at all. Or them. That kind of leads me to my next point, which is creating a clean, noiseless visual. As an illustrator and a technologist, I spend a lot of time getting into the weeds, sort of getting into the nitty-gritty details of how things work. While I'm in the process of wrapping my brain around something, it's really hard for me to draw a clear and concise picture because I get bogged down in all the details. This illustration, for example, shows many different systems of the body overlaid one on top of the other. Someone who's concerned with, say, heart health or the location of major arteries in the body will most likely be interested in the third diagram here. It's not that the location of the muscles, bones, and nerves isn't also important, it's just we're removing them from this diagram so we can see the facet that we're focusing on more clearly. Once I'm really solid in my own understanding of a subject, I find it a lot easier to depict just what's important and get rid of the noise, because I know it's noise. For example, does your audience need to know the entire content and the HTTP request that a client sends to the server, or will arrows suffice? This drawing is fine for helping explain the general flow of a request that hits the database, but it's really not great for explaining routing or how the client knows where to send the request. That might be fine. You can also include semi-concrete examples in your illustrations, showing a use case versus showing abstractly how something's supposed to work. It can help bring your example into the realm of your audience expertise. So this diagram is a depiction of an imaginary message queue and the systems it talks to. A user service picks up on a new user registering for a program and sends out a message. The message queue is listening, note the ear, and it broadcasts this message out to other services, which are also listening with their own tiny ears. They can then do whatever they need to in response. So this diagram is helpful to show someone who's familiar with these imaginary services where we expect a particular message to be broadcast and which systems could pick up on it. But it really doesn't tell you anything about the how or the content of these messages. In a case like this, you would get into that later. This would be your high-level sort of map of where things are. This brings us to making it memorable. If you provoke an emotional response in the user's mind, humor, empathy, you're linking this idea even more strongly into their minds. You're making an impression that's going to stick with them. I like to think of this as like you throw an idea at the wall of someone's brain and then you stick tape on it. The more different ways you can come at it, the stickier the idea will be and the more likely they are to remember it. This silly software bug as actual bug drawing is an example of using humor to drive a point home. If you can keep the image of two caterpillars on a branch that can't get around each other in mind, the idea of a program running into deadlocks is a lot easier to think about and reason around. Regardless, whatever you're depicting, you'll want your drawing to be clear and understandable. These examples that I'm going to show you will demonstrate a few formats that have helped give me some structure in the past. When I'm thinking about how to model relationships different pieces of data have to each other in my applications, I like to draw out an ERD, or an entity relationship diagram. This kind of diagram is perfect for showing how one thing relates to another thing. We can show different kinds of relationships between entities using different kinds of lines. For example, this branching line here is known as a crow's foot, caw, and it indicates that one entity can have many of another. A user has many blog posts that they may have authored. A user has many favorites that they have maybe favorited somebody else's blog post. But you can only favorite one blog post at a time, and a blog post can only be authored by one person. You can get really detailed with it, but I usually like to try and stick to simple drawings like this. A sequence diagram is really great if you need to show the order that things happen in. It's really nice for when you want to show how a request travels between different systems. So each system here is its own separate column. We have the browser, the server, and the database. The browser goes ahead and loads the HTML. It makes an AJAX request for cat pictures to our server. Server asks the database, hey, what cats do you know about? Database sends back all the cats it knows about. The server serializes those records and throws them back on over to the browser, where it can render a beautiful list of cats for your viewing pleasure. There's also a lot more that you can do with these as you get more specialized, but the gist is columns with arrows showing the sequence of events. Visual analogies also have their place in finished documentation. The analogies in your mind are hard-won. Learning something new takes a lot of effort. These analogies can help others understand the same concepts without going through all of the pain that you went through, so I recommend sharing them if you can. Now that you know a bit more about creating clear, concise, and impactful illustrations, you may be thinking about how you can bring the practice of drawing into your daily work. I personally like to keep a paper notebook around for easy scribbling, but you can use any tool that works for you, be it Glyphy, be it a Miro board. You don't have to physically draw this out to get the benefits of it. The general flow that's worked for me goes like this. 1, I have to know what I want to understand or communicate, so I have to set out and define the problem up front. That way I know what to look for. 2, I need to test that what I know is actually true, test my knowledge, sort of test the boundaries, push on a little, see if it falls over, by observing what's happening in reality. Once I know that what I know is true, I like to sketch out the big picture. So I sketch out how my idea or the concept I'm looking at fits into the picture in my mind, contextualize that information. Once I've done that, chances are I've got more questions, so I'm going to do some more detective work and refining and fill in the details. Finally, do it all over again. You're never going to stop having questions. You're never going to stop learning as a software engineer. So the more you do this, the more practice you get, the easier and more effective your drawing sessions are going to be. I found that including visuals and diagrams in my engineering proposals has helped grab folks' attention. It makes it more likely that whatever I'm proposing is going to get viewed and reviewed. Even if my visuals highlight a concept or an idea that's incorrect, Just having more eyeballs pointed at it makes it more likely any mistakes will be corrected quickly and collaboratively. And I'm 100% for collaborative problem solving. Visuals can also help you out by helping you present a convincing and compelling argument for your ideas. So more than just sort of giving your audience something fun to look at, visuals can help folks see your idea as something that could be real. They see it on paper, they see how it might work, and it seems like something that could come to fruition in reality. So when you're trying to convince other people to give your idea a shot, this is really nice. As I progress in my career, I continue to struggle with new information and new technologies. I know that these are just growing pains as I deepen my understanding in one way or another. It's just something that, it's a sign of progress. As we draw to a close on the talk, I hope to leave you with some tools to keep making that progress, to keep getting better, and to share the truth that building understanding and sharing knowledge that you have, these both demonstrate mastery of a subject and mentorship. And these to me are both signs of a mature engineer. As you create drawings and diagrams, please keep in mind that you're building your own mastery as you communicate to a new audience. Drawing out the way your system works and stripping away the things that don't matter strengthens your mental model of how it really works. To be an artist is to build understanding. Just like artists, we need to spend time and effort practicing and giving careful consideration to the tools we work with day to day. The more time we spend being thoughtful and observant, the stronger our understanding becomes. Becoming a senior technologist is also built on building understanding. Our responsibility as we progress in the field is not only to master our craft, but also to build up those around us. I hope that you'll be able to use the tips in this presentation to create strong visuals and help get the ideas in your head out onto paper where you can assess, elaborate, refine, and share them. Also, good luck explaining what OAuth is without a diagram. Thank you very much. My Twitter handle is here, so get in contact with me if you have any questions. And thanks very much for listening to my talk.